And the last bit of this, what is the ball's acceleration each second? Well, what is it that's accelerating it? It's gravity, right? And what is the acceleration due to gravity? Well, negative 9.80 meters per second squared. So if I were to put that in each of these, every second its acceleration is negative 9.80 meters per second squared. Here, 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 here. It does not matter if it's going up or if it's going down. We can think of it as the ball is going up, it is losing 9.80 meters per second of velocity once every second. And then when it starts to come down, it is gaining that much velocity in the negative direction. Many people will say that its velocity is becoming more negative. You can see that. It starts at positive 25, it gets closer and closer to 0, which is a negative direction, and it comes back down. Okay? Speaking of zero velocity, is there ever a time where the ball's velocity is 0? Well, yes. If we look at this, right at the very top of its arc, we can see v2 and v3, somewhere between 2 and 3 seconds, the ball's velocity changes from being positive to being negative. Right? We've got this kind of thing. Best to demonstrate this graphically. So if we make a velocity versus time graph for this, with positive 25 meters per second right there, there's my 5th second. What we see is that at some point between 2 and 3 seconds, some point there, the velocity has to be 0. And we'll see if it's constant acceleration, we're going to end up with a slightly tilted line like that. It should be straight. You know, this is me just doing a freehand with a marker. Alright? So this is what our velocity versus time graph should look like for this situation. And we can see at 5 seconds, we're almost back where we started from. Right? Obviously, this graph not drawn quite to scale, but we're almost back where we started from. Okay? The end.